So here we have it, folks. This kind of complicated statement ends up being this plus this plus this plus this. And those combinations are 1, 3, 3, and 1. And you plug in for the exponents. And the crazy thing with this super complicated expression is that when you add all those together, you get 1. And we'll be looking at why that is in a lesson shortly. In the meantime, I want you to look at 2 more series problems on the back page. And the first thing you're going to notice is that this right here is pretty bonkers complicated. See how it says we're taking, that should be an I, by the way. We're taking the sum from I equals 0 up to 100, which would be 0 plus 1 plus 2 plus 3 plus 4 plus 5 plus... Okay, and we keep adding until we get all the way up to 100. Now, mathematicians are lazy, and we really don't want to have to do this kind of ugly calculation. And so that's where these special series formulas come into play. And you'll notice that this one right here is like the example that we're looking at in E, because the sum is I. It doesn't really matter that this starts at 1. I could have started this one at 1, and it wouldn't have changed the value of the sequence at all because we would just be like dropping a 0 off. So what we're going to do, rather than actually adding all of those numbers up, is we're going to use this formula, n times n plus 1 over 2, where that n is the end of your series. So the answer to this will be 100 times 100 plus 1 divided by 2, which is 100 times 101 over 2, which comes out to be 5,050. Okay. Typo again on F. This should be an I right here. And on F, we're going to play the same game. As soon as you see that there's a really big number here, it probably is telling you that there must be one of these shortcut formulas. So on F, we would use this one right here. So you're going to take this and you're going to plug that formula into it. So n is 100 times 100 and plus 1 times 2 times 100 plus 1 all over 6, which is 100 times 101 times 201 over 6, which comes out to be 338,350. One of my favorite numbers. That brings us to the last part of the lesson. In number 2, what I'm going to ask you to do is take a series of numbers and write it using summation notation. So let me show you how to do that. First, let's imagine this is term 1, 2, 3, 4, and 5. So our index is going to start at 1 and it's going to end at 5. And then you'll notice that in each one of these problems, the term number shows up in the denominator. What that means is that each one of the terms is 1 over I. So this is this statement written in sum notation. Okay. Let's try the next one. Take a look at B. Here we have term 1, 2, 3, 4, 5, 6. So summation, starting with the first term and ending with the 6th term, where each one of these terms is the term number squared. Therefore, I squared goes in this position, and that is our answer. Continuing on to the next one. Here we have term 1, 2, 3, 4, and then a bunch of stuff happens in the middle, and then we get an end term right there. So I can tell you immediately that on this one, we're going to start at I equals 1, but we're going to have to think about it to figure out what goes right here. So for now, I'm going to suggest that we notice that this is going up by 2, up by 2, up by 2. So the 5th term would be 10, the 6th term would be 12, the 7th term would be 14. And if you keep counting up, you can see that between 8 and 30, 8 minus 30 is 22. So we need to add 2, divide by 2, 11 times to get up to 30. So if this is the 4th term, this will be the 11 plus 4 equals, that will be the 15th term. You can also kind of see that that makes sense, because if you look at the relationship between these, the term value is always double the term number. So 15, you double it, you get 30. So we're going to end at 15, and then each one of the terms is 2 times I. Now for the last one. Term 1, term 2, term 3, term 4, term 5. When you see something that looks like this where all the terms are the same, first start here. The first term is 1 and the last term is 5. And no matter what the term number is, the value is always 1. So the number that's going to go right here is 1. And we're done. I want you to get started on assignment number 4, which will be coming in next class.